Okay, let's have the last problem for this session. This is a cute problem, which is on funnel boss. Kaya siya boss, you'll see why when we solve the problem. So a particle of mass m1 is attached to another particle of mass m2. The first mass is constrained to move in a uniform circular motion inside a rotating frictionless funnel with opening angle theta, while the second mass is freely hanging. Let r be the radius of m1's orbit. So again, we have a particle uh, that is rotating on a cone. So may cone ka dyan na umiikot yung cone. Tapos, yung M1 ay nandun sa cone, tapos connected siya by a rope to an M2. Now, the question here is, of course, we can draw a free body diagram of it, we can set up the equations of motion, but the question in this particular problem is, what should be the velocity, the tangential velocity of M1 for M2 to be stationary? That is the question of this topic. So what I will do is to explain the solution and to you and to solve this problem in this class. Okay? May tanong ba? Wala? Walang questions? May mga tanong ba? Okay, wala. Okay. Okay, so again, let's solve this problem. So, ang mas madaling gawin is first hanapin muna natin yung M2, yung condition for M2 to be remain stationary. Because what we want is for M2 to remain at rest or to remain stationary. So first we will draw a free body diagram for M2. So paano drawing a free body diagram? So again, we have what are the forces acting on M2? Dalawa lang naman yan. Similar to the previous problem, dalawa lang yung forces na nag-act kay M2, which is tension pointing upward and weight pointing downward. So tension and weight. So yan. So again, I'll draw a big dot here. Tapos, okay, so ayan, so okay, and for this is blue, this is darker. Okay, so this is tension and this is weight. Now, what we want is for M2 to be stationary. So if we set up the equation of motion of that, what will happen is that summation of forces acting on y for the second object or for mass 2 should vanish because ayaw mong mag-accelerate yung M2. So in that case, we have this is just equal to t minus mg, minus, this shouldn't be mg, this should be m2g, I should say. This should be m2g. Sorry for that. And this should be minus m2g, implying that the tension must be equal to some m2g. Okay? Clear ba tayo dito? Is this clear? I hope this is clear. Okay. Now, okay, let's have some fun. So, okay, ang tanong ngayon, how is the tension related to the forces acting on the first mass? So that will be the second condition. So, ang gagawin naman natin ngayon is we draw the free body diagram of M1. Okay, when we draw our free body diagram, ang lalabas dyan ay ganito. So, first, I will draw, hindi pa pala. Okay, sorry for that. Kailangan ko muna mag-drawing ng curve. Drawing ko muna yung incline. Drawing ko yung incline. So, ganyan. Stand ko ito ng konti. Tapos, i-drawing ko yung triangle. So, yan. So, yon. And then, what are the forces acting on M1? So, again, it's on an incline and on a funnel. Well, technically, it's an incline, pero pinaikot mo ngayon yung incline na yon. So, kaya nagkakaroon ka ng forces. And then, in that case, what are the forces? So, you have a normal force perpendicular to the incline. Masyado manipis. Sorry for that. Dapat ito ay makapal. So, ito ay normal force in this direction. Then, we have another force that is downward, which is your weight. Weight is always pointing downwards. Okay. And then there's another force. The force also of the rope exerted on M1. Because remember, the boxes are connected by some rope, and that rope is exerting a force on a tension on M1. So meron ka ngayong tension dito in this direction. So paano yun? It should be along the incline pababa. Okay, something like that. Okay, so we can label it as follows. So this is some tension. This is some normal force N. This isn't clear. So this is normal force N. So this is normal force N. This is the tension P, and this is the weight of the object of the first object m1 g vector. Now, okay, so these are the forces acting on m1. Now the second question now is, what is the direction of the acceleration of the particle? So this is crucial because it will be our basis for determining the tangential velocity that we want. Remember that the M1 is rotating. Rotating siya, umiikot siya, tapos, therefore, if I enlarge this figure here, I have a funnel here. I have a funnel. I have a funnel. This is the funnel. The box here is moving in this direction, is pointing in this direction. As I said in the previous problem, the direction of the acceleration should be center seeking from the circle that is created by the motion. So for example, here, I can create a circle here, and therefore the direction of the acceleration is center seeking. Therefore, it should point at the axis of the funnel. Hence, in that case, the acceleration therefore is pointing towards this direction. That should be the direction of the acceleration. Now what I will do, since I will use this diagram, I will enlarge this diagram. I will enlarge this diagram for us to have a clearer view of what will happen. Okay, I'll just place this center of acceleration in this direction, maybe in here. So the direction of the acceleration is that. Now I will write a coordinate system. I will construct a coordinate system such that the direction of the acceleration is parallel to one of the axes. So in that case, what I will do is I will create a coordinate system, one parallel and one perpendicular to the axis of the funnel. So the one perpendicular to the axis of the funnel is the radial direction, and the one parallel to the axis of the funnel is the tangential direction. Now, we know that the angle of the opening angle or the cone angle of the cone is some theta. And therefore, if this is theta, I can construct, so this is the funnel, sorry for that, this is the funnel, this is the cone. So I have a theta here. It means that if this is the particle, I can construct an angle here, theta, which is the same as the cone angle, and that angle is the angle with respect to the vertical of the cone. In that case, I can say that this angle here is also theta. Okay, now theta here and this angle, this second angle here, they are complementary to each other. They are complementary angles, and therefore, if this is theta, this is also 90 minus theta. And then this is also complementary, right? This will, sorry for that. This will form 90 degrees again, and say that this angle here is also theta, because n vector is the normal vector, the normal force is perpendicular to the direction, to the surface of the of the of the of the funnel. Now, so this is theta, and this is also theta. However, t here is 90 minus theta. It's complementary. Now, from there, I can now determine or set up the equation of motion. So summation of forces acting on the radial direction for the first object is simply, I have an n cosine theta, and then plus a t. So this is now opposite. So instead of cosine, we have a sine theta. And this is just equal to m1. Again, the direction of the radial direction is the direction of the centripetal acceleration, m1 v squared over r. Okay, and then for the second one, you have summation of forces on the radial direction, or sorry, for the tangential direction of the first object. What will happen? We don't want an acceleration in the tangential direction, because what will happen there, if there's some acceleration, is the box will move upward, up and down. You don't want that. You don't want the box to move up and down from the incline, and thus this will just vanish and say that this is simply n. This is simply n sine theta minus t cosine theta minus m1 g. Okay, So I have three equations. The first one is this component, this equation 1. I'll rewrite this. So this means I have an m1 v squared over r equals n cosine theta plus t sine theta. This is my equation 1. My second equation is, again, an, uh, an n sine theta equals t cosine theta plus m1g. This is my second equation. And my third equation is simply t equals m2g. This is from the equation of motion of the second mass, which again we want to be stationary. So this is equation 3. Now, substituting equation 3 to equation 2 and equation 1, we can substitute equation 3. We will get something like an m1 v squared over r equals n cosine theta plus m2g sine theta. And then an n sine theta equals m2g cosine theta plus m1g. Let's say this is equation 4 and this is equation 5. And from that, solving for n, in equation 5, we have an n is just equal to m2g cosine theta plus m1g multiplied by 1 over sine theta. This is equation 6. Okay, I now have an expression for the normal force. Again, the normal force is not given in the problem. The only ones given are the masses of the objects and the cone angle, or the angle of the cone relative to the vertical. So that theta here, that theta. And from that, I can now, since I have now the normal force is known in equation 4, I can substitute equation 6 to equation 4 so that we get something like an m1 v squared over r equals a large expression m2g cosine theta plus m1g. Now, what I have a 1 over sine theta here, I have a cosine theta here. So therefore, cosine over sine, I have a cotangent theta here plus an m2g sine theta. So this is equation 7. And thus, I can divide, I can multiply by r over m1, and thus I can simplify this. Isolating m2, or combining m1 and m2, I have an m1g cotangent theta plus m2g multiplied by cosine theta cotangent theta plus sine theta. Tama? Tama, di ba? Tama? Cosine theta, cotangent theta plus sine theta. And thus, from there, we have shown that, or I should say, thus solving for v, we have, therefore, v is just equal to square root of rg multiplied by cotangent theta plus m2 over m1. So what I did is to factor out m1 in this expression here. I factored out m1 in this equation. Sorry for that. I factored out m1 in this expression here. So, and therefore I have an m2 over m1. I factored out my g, and thus I have a cosine theta cotangent theta plus sine theta, and thus this is just raised to 1/2. This is the expression for the velocity needed for m2 to be at rest. Okay? Malinaw ba to? Is this clear? Is this clear? Malinaw ba to? Okay? Are there any questions in this item? Walang tanong? Wala? Okay. If there are no questions, okay.